finding planets with the right kind of atmosphere to support alien life is something astronomers are constantly striving towards. Researchers have now found another potential habitat that could harbor ET in the clouds of cold planet-star hybrids known as brown dwarfs. A brown dwarf is a type of failed star that is sized somewhere between a giant planet and a small star. The astronomers found that the pressure and temperature found in brown dwarfs' upper atmosphere is very similar to Earth, suggesting it could be the perfect spot for alien microbes to grow. The researchers estimate that 1 billion brown dwarfs exist in our Milky Way galaxy, with plenty relatively close by at around 32 light-years away. Previous studies have argued that brown dwarfs hold many of the key ingredients for life, including carbon, hydrogen, nitrogen and oxygen. The finding may mean that science must abandon its idea that extraterrestrial life needs land and water to survive. Brown dwarfs are smaller than stars, but more massive than giant planets. They could help shed light on how different planets form their atmospheres. But because they come in a huge variety of shapes and sizes, exactly how they themselves form has, until recently, been difficult to understand. Brown dwarfs are mostly made up of large plumes of swirling gas, and a team of planetary scientists from the University of Edinburgh investigated one such object called WISO 855-0714. This brown dwarf was discovered in 2013 and sits around 7 million light-years away from Earth. The gaseous body is of particular interest to scientists looking for extraterrestrial life because it is colder than most brown dwarfs, giving relatively mild temperatures that are similar to Earth. The team used calculations from noted scientist Carl Sagan, originally intended to investigate the possibility of life on Jupiter. As Jupiter is a gaseous giant, these calculations took into account that the organisms would not need solid ground to survive. You don't necessarily need to have a terrestrial planet with a surface. Co-researcher and planetary scientist Jack Yates told Science. The researchers also considered the nature of plankton living on Earth to examine whether similar forms of life could exist within the gaseous clouds of a brown dwarf. We argue that an atmosphere sitting above a potentially uninhabitable planetary surface may be cool enough to sustain life, the researchers say in their paper. By doing this, we define an atmospheric habitable zone with 1 billion brown dwarfs to investigate in our galaxy alone. The researchers suggest that there is plenty more searching to be done in the quest to find extraterrestrial life. The idea remains hypothetical for now, though, and work must go into proving the existence of any brown dwarf microbes in future. The finding comes after Washington-based researchers revealed brown dwarfs' potential value in the search for alien life earlier this year. Dr. Jacqueline Faherty from the Carnegie Institution for Science in Washington recently surveyed various properties of 152 suspected young brown dwarfs. She found atmospheric properties could be behind much of their differences. This could shed light on the exact form of brown dwarfs. The work, published by the Astrophysical Journal Supplement Series, could also help us to understand the atmospheres of planets outside the solar system. Understanding the atmospheres of brown dwarfs will help us to learn more about the atmospheres of planets that were formed around the same stars as they were. This will help astronomers work out whether planets have an atmosphere similar to Earth. Brown dwarfs hold promise for explaining not just planetary evolution, but also how stars form. The objects are tougher to spot than more massive and brighter stars, but they vastly outnumber stars like our Sun. Brown dwarfs are far easier to study than planets because they aren't overwhelmed by the brightness of a host star, Dr. Faherty explained. By looking at the properties of hundreds of brown dwarfs, Dr. Faherty and her team showed the range of properties was not brought about by difference in age or chemical composition. I consider these young brown dwarfs to be siblings of giant exoplanets. As close family members, we can use them to investigate how the planetary aging process works, Dr. Faherty said.